Hello and welcome to my channel. In this video I'm going to show you how to install Reticulum Meshchat on a Raspberry Pi because it's nice to have it running on a small machine with low power consumption, which you could perhaps connect to an RNode, a radio node, and then put in a remote location running on batteries, and maybe that's going to be solar powered. So the first thing, of course, is to get the Meshchat software running on a Raspberry Pi so that you can chat in the Reticulum network. And I've chosen to do this on a Raspberry Pi 4 because I've got one. I think it's a 4B, maybe that's the only one I made. I'm not sure how much RAM is in it. It's either 4 or 8 gigabytes, but either is plenty. And all I needed to do is to find this page on GitHub from Liam Cottle, who's the author of the Meshchat software, and he here has published instructions onto how to install Meshchat on a Raspberry Pi. And I'm going to follow these letter by letter to see if it works. And there's one caveat here, one thing to watch out for, is that if you use these copy buttons to copy the commands, and of course it copies everything in this box, and you can't just paste that into a terminal window, it won't work. You have to paste these lines individually, especially when you get further down here, where things get more complicated. You need to recognize that each of these is an individual command. So if you copy this with this button, you're going to get this whole chunk. So what I've done is I've copied and pasted each of these boxes of commands individually into a note here, and then separated them out with spaces a little bit, the longer ones, so that I don't make the mistake of taking them together and pasting them into a terminal window. And what I'm going to do is I'm going to install the Raspberry Pi operating system headless. That's what they call the light version on the Raspberry Pi installer, because I don't need to have a monitor and a keyboard plugged into that Raspberry Pi. It's going to be remotely mounted. So by having it headless, there's less overhead of software running, and also I'm going to then connect into it using SSH via the network. And I've actually got the Raspberry Pi plugged in with an Ethernet cable because I don't want to mess around with Wi-Fi at the moment. Once I get it working, I would enable Wi-Fi later. You see how popular I am with all these messages rolling in. Joke. Anyway, so the first thing to do is to install the Raspberry Pi operating system. I'll put these links in the description below as usual. You need this one, raspberrypi.com/software, which is this. And you need to install this program here, Raspberry Pi Flasher, whatever they call it, Imager. Yeah, I'm running this on Ubuntu Linux at the moment, but of course you can do this on Windows or Mac OS, and it will work just as well. So on Ubuntu, the easy way to do this is just go to the manager for software. This is the Ubuntu Software Manager. Search for Raspberry Pi or Raspberry or Imager or whatever you find this. I've already installed it, and these days I've learned the hard way to set the permissions, because sometimes it doesn't have the permissions it needs. And the important thing is here is to be able to write to the micro SD card that I'm going to plug into it. And somewhere in here will be the settings, read system mount information and disk quotas, access files, access hardware information, read and write files on removable storage devices. Yes, that's very important, because if that's not set, it won't be able to write to your card. So, as I said, I've already installed that. So let's just clear the screen a bit. Let's go and run it. So you look in here on Ubuntu, and it's there, Imager. And there it is. So what I need to do is choose the device. If you already know how to do this, you can skip all this, of course, but I thought I'd go through every step of installing this software on a Raspberry Pi. So I've got a Raspberry Pi 4, Model B in fact. Operating system I want is none of these. The light versions, the headless versions, are here. That's without the GUI, graphical user interface. Raspberry Pi OS Lite 64-bit. Debian Bookworm. This is the one I want. Bookworm is the later version. There's an earlier one which had another name I've forgotten. This is the one I want to use. 64-bit version, and it's light. So it's only about 500 megabytes as well. So that's that. Where am I going to store it? It's plugged in. I've got a 32 gigabyte SD card plugged in, micro SD. So I'm going to put it on there. And then I'm going to apply some customization settings. Let's edit them. And I've already put these in. I put in a host name for the device instead of their default one, because if you have a number of Raspberry Pis all with the same default name, it's going to get confusing on the network. So I've just called it Raspberry 8. You have to check these boxes. I want to set a username and password to log into that via SSH later on. Username is user, password is whatever. What else do I need? I don't need Wi-Fi at the moment, and I don't care about time zone at the moment. Services, I want to enable SSH, so I've turned that on using password authentication, which means that I can just use that username and password to connect to the device. Options, not really worried about those. Oh, enable telemetry. Let's turn that off. So, save. And then all I'm going to do is say, do I want to do this? Yes. And it's going to erase everything on the card. Please don't do this on a card that contains important data because you're about to lose it. Yes. Oh, password. So that goes in, and it's going to write that image, the headless operating system, onto that micro SD card. Now, I'm not going to make you watch it do this because it's going to take it probably 5 minutes. So what I'm going to do is pause the video and resume when it's finished. So the flasher has finished flashing. What do they call it? Imager. Okay, it's finished. You can now remove the SD card from the reader. Great. So I'm going to unplug it, and I'm going to plug it into the Raspberry Pi, and then I'm going to start that up. Now, the first time you start a Raspberry Pi with a fresh flashed operating system on the micro SD card, it takes quite a long time to boot because it has to do all kinds of expanding file systems and doing different things. It kind of continues the installation, or it installs itself, and eventually it is ready to work. And because I haven't got a monitor plugged in, I won't be able to see that happening. But what I will do, I will SSH into it after a little while. But you have to be patient. If it doesn't work at first, just wait until you can actually connect. So let's go ahead and do that. So the Raspberry Pi has had time to start up now, and if you look at the Ethernet connector, the yellow and green lights come on after a while and they flash occasionally. It shows us some activity. So I'm going to try now to connect to it using SSH from the terminal, and you can also do this with Windows from the command line or Mac OS. So I'm going to SSH into the username is user at, what is it? Now, if you don't know the IP address of your Raspberry Pi, which you probably don't, for the first time, if you're doing this headless, the easy way is to look in whatever router it's connected to, the control interface for your router, and then see what devices are connected. And I can see I've got an extra Raspberry Pi there called Raspberry 8, I think it was, and then I can just read the IP address from there. So the other thing is, if you've used the Raspberry Pi for other projects, then it will always usually get the same IP address from your router. You can even tell it, the router, to always give the same IP address so that it's guaranteed to be the same without actually fixing it in the Raspberry OS. Anyway, 192.168.8.202. Of course, your IP address could be totally different. Ah, there we did. I got it right, it connected. So you need to find that out somehow. And then it's in the first time you're connected, so do I trust this device? Yes. So it's to do with the fingerprint. What's the password, which I set during the flashing of the SD card? It's that. That's the name of my other cat. So, looks good. Wi-Fi blocked by RFkill at the moment, and I haven't set the country. Oh dear, what a shame. So what do I want to do now? Let me see if it really works. ls-al. So that's what's installed in there at the moment in the home directory. Very little, no home folders with videos and documents and stuff. It's just this. So what I need to do now is to update it before doing anything else, because it's a fresh install and there'll have been some updates since that OS was released. I have to do sudo apt update, and the password is still fresh, so it didn't ask me. And then the next step might take a long time, so I might pause the video again. This is just updating the package list that's been updated as well. Okay, then we want to do sudo upgrade and let it do its upgrade thing. Yes, just press enter because that's the default, and it's getting all these upgraded files and it's going to upgrade the OS on the Raspberry Pi. What I will do after this is finished is I will also reboot the Raspberry Pi just so that these things can take effect properly, just in case, and then I'll go ahead and install the Meshchat software. So I'm going to pause the video again and come back once this is all finished and I've rebooted. I'm actually going to show you how to reboot the Raspberry Pi from the command line. So I didn't reboot it yet, and what I'm going to do is show you how to do that just as soon as it's ready. I thought at 99% it might be close enough to the end, but the last stages usually take longer, which is something I forgot. Anyway, on an Ubuntu machine, you just type reboot, but I think this won't work. No, it didn't. So you need to do sudo reboot, or you have to be root to do this. So there we are. Now it's rebooted, connection closed, and I'm back to the command prompt from this Ubuntu machine I'm using as a terminal. So I'm going to pause the video again and then come back after it's rebooted for real this time. The Raspberry Pi finished rebooting, and in the meantime I thought of a neat way to check if it's actually rebooted or not is you just ping it. So that's the IP address for the Raspberry Pi, and then you ping it, and 6 milliseconds return path. It'll ping forever. Doesn't time out after 3 pings like Windows would. So Control C to stop it. So that's working. So now I can connect to it again with SSH. So that's that. I'm just using the up down arrow keys to recall the commands, and password, and yeah, it still works, and it's been updated. So what I'm going to do now is to copy paste in the commands exactly from the GitHub page, which I've written in my note to separate them out. And the first one is that one. So I'm just going to copy it. Could have used Control C, but anyway. And then I'm going to paste it with Control Shift V. Oh yeah, with Ubuntu it's Control Shift V. If you're using Windows it's Control V. And if you're using a Mac OS, it's Command V, I think, or whatever they call it, that button with an apple on it. So that's that. And we're going to install Git so that we can download software from GitHub. Are you sure? Yes. Just press return for the default yes. While it's doing that, let's copy paste the next command, which is this one, to install pip, the Python package manager. So Control Shift V. Press return and install pip. Some of these commands that I'm installing things might take a very long time, in which case I'll just pause the video because you don't want to watch all of this. And of course if there are errors then I'll start the video again so we can look at what went wrong. The next command to paste in is this one, and I'm going to be honest with you, I actually made a mistake because I did paste it in and it worked fine. And then, unfortunately, I wasn't paying attention because I had a problem with my HDMI video to USB converter. The picture was jumping around horrible, and I fixed that. And when I came back, I made the mistake of copying only this line and pasting it into the command line, and of course gave a strange error. I hadn't noticed it was the second half of this command. And then I carried on through the next steps, and it all went very wrong, and I couldn't recover. So what I had to do was to start again from scratch. And this can happen when you're doing things like this. So I had to flash the SD card again, reinstall Raspberry Pi OS, go all the way through the whole thing, which takes some time. So be warned to make sure you copy paste these things properly. So what I need to do now is copy paste this command in. I've got back to the same stage I was at before, Control C. The problem is if you flash the firmware again and then try to use SSH, it's going to have a different key. And then you get this warning. The identification has changed with the device, and so you can't connect to it. So what I had to do, luckily they tell you how to overcome this. You just have to use this command, generate a new key, which is known, and put it in the known hosts file. And what happened was the original key has been, or the file containing it has been renamed as hosts.old, known hosts.old, and hopefully now I can SSH back in. So be careful when you're copying these commands. It goes wrong easily. So hopefully now, yes, I am allowed to connect, and I have to say yes, I accept the new fingerprint. So that's that password for the Raspberry Pi, which is that. Okay, so now we're back in again. So that can cost you quite a lot of time. So now I can put in that command that I got wrong earlier on today. So that's done. And this time, don't copy the second line only, copy this. This sets the version of Node.js that we want to install. So Control-C, Control-Shift-V, pop that in there. And then, moving along, this is the next command. Again, it's a 3-line one as it's on this particular notes page. To put the signed package list in there. So let's do Control-Shift-V. So that's added that to that file. Good. And then we have to do a sudo apt update so that we can look at that new repository. This is the next command to install Node.js. So I'm going to do sudo apt update. Shouldn't take too long. And now it's going to include the new Node source in there. So when this is done, I can paste in the next command. Okay, that's not a bad warning. You always have to check the warnings. So Control-V. And this is installing Node.js on the Raspberry Pi, which hopefully won't take too long. I've got a feeling that I might have to reboot at some point because the path settings won't be right to point to these Python. We'll see. Let's assume that that's okay so far. So the next command is this one, to clone the software from GitHub for the Reticulum Meshchat program. Control-C, so I'm going to paste that in when it's ready. Now it's ready. No errors, okay. Ah, that's interesting. Git not found. Somebody forgot to install Git, didn't they? That's because I had to start again from fresh, and I did update and upgrade. I forgot to start here, so let's do that now. Let's install Git. Yes. Of course, you would normally do these in the correct sequence that's shown on the website and not jump around like this, but there you go. You see how tricky this gets. Quickly goes wrong. So then we have to install pip, the package manager for Python, which is already done if you followed through from the beginning. It's just because I had to go back and start again. So that's installing pip. What comes next after that? Okay, that's what I just did and I got it right this time. So that should be okay by now. We're installing pip, Python package manager. Yeah, so I had to jump back because I reinstalled the whole Raspberry Pi, which you wouldn't need to do unless you made a mistake with one of these lines. This line I've already installed, or done properly, and I did this properly, and I did this properly, and I did the update. So the next command is to install Node.js. No, it doesn't. That worked. The next command is this one, to clone the package. It's already in the command line. I could use the history, but I'm going to copy paste it as you might want to. Control-C to copy it. And then I'm going to paste it into here. And this time it works. So now it's downloaded the software, 5 megabytes. Okay. So change directory. Just type tab to finish the line. There it is. What's in there? Okay, looks good. And now I'm going to install the required Python packages. This could take a long time. Let's see. It gets them from a file called requirements.txt that should have been in there somewhere. And this will take perhaps a minute or two to install. And then this is where it didn't work last time I did this, which I edited out. This is the next command, to use npm to install this, or to install npm, I mean. And last time I got errors that I couldn't fix because of the problem I'd had earlier. So let's hope that this time it will work properly. It may be I need to reboot because all of these warnings are saying that these things are not in the path. I could add them manually, but let's see what happens if we just do this. Well, it looks like it's working. You can see a little working symbol down there. So maybe I'm not going to have to reboot. Let's see what happens. It may throw up errors. Whilst, oh, it finished. npm's installing. Let's have a look, see what it did. npm install 195 packages. Wow. Vulnerabilities are always interesting to have. Okay, so it looks like it's installed. So now we can use npm to do this. There's the postman, Control C, post person, sorry. Let's see if that's going to work. Looking good-ish. What comes after this? Oh, the next command is the one that's going to actually run the Meshchat Python program. Headless. This host address 0.0.0.0, you'll see later that it allows us to connect using the IP address of the Raspberry Pi with that port number. So let's see if that's going to work. Yes, doesn't look too bad. So Control-Shift-V, let's see if it will run. So this is the Meshchat program starting. Oh, it is running. Look at that. There was no config file because it's the first time it's been run. So it created a default config file and it looks like it's working. So to see if it really is working, of course, this is a headless system, so there's no graphical user interface. What will happen is messages will pop up here as things happen. Here we go. It's received announces. Let me make an announce from another machine on my desk here. Announce. That's X230B. So that is working. It's receiving announces on the Reticulum network. So how are we going to connect to it? I'm just going to copy paste the IP address for the Raspberry Pi that we already know with :8000, that's the port number. Open a new tab with Control-T, Control-V to paste, press enter, and boom. Goodness me, it works. You can tell I'm happy because that should have been a straightforward installation, but it went slightly wrong and I had to fix it along the way. So now it seems to have worked. So this is the Meshchat program that we're viewing using a web browser at the IP address of the Raspberry Pi. Now this is wonderful because you can then take the Raspberry Pi and put it somewhere else, like in the loft of your house or up a tree or somewhere, and you can still connect to it using the this web interface, as long as you've got a network connection, which you could achieve with an Ethernet cable or with Wi-Fi, which I turned off on this Raspberry Pi, but that could be added later. I like to do these things in stages. Get this working first before messing around with Wi-Fi, and so it goes on. Yeah, so it works. Let's see what's set up. So it's got the default interface configured and working. Hasn't got a name. Let's call it RESPI8 because that's the name of the machine, so I know what's what when I see it later on my network. Yeah, it works. Settings, what's been done here. Okay. Straightforward default settings. Network visualizer shows you, oh, this reminds me, that I like dark mode because it's more relaxing on my eyes, so you can quickly switch that using the settings. Light theme to dark theme. Ding. Okay, let's look at this again. This is the fun part where you can drag this thing around. So, wow, it works. Raspberry 8 is that Raspberry Pi I just installed this on. This is the default interface. It's already picked up some nodes in the Reticulum network, anonymous peer, F4EKB, it's a radio amateur in France. Somebody's Pi node, another Raspberry Pi has popped up. Interesting. X230B is my my machine that's running NomadNet that you've already seen if you've watched the other videos. So it's being active in this network already. What's on there? There's already one node. Look at that. That works. Hello to Kilo 40 if you're watching this video. Wow, it works. And this is the little Raspberry Pi hosting this program, and it's accessed via a network connection. Good, I'm happy. So there's one other thing perhaps you could do while you're here. I'll show you. You can see that it's busy working. Let's stop it with Control C, and let's go and edit or at least take a look at the config file with the default configuration, which is not in that Meshchat directory. Let me show you. Let's go up a level. Actually, I've forgotten where it's going to be. I don't think it's going to be there. Let's have a... No, I don't think it's in there. I think it should be in the Reticulum directory. Oh, I know why I'm not seeing it. Yes, you have to do ls-al to show hidden things, hidden files and hidden directories, and here it is, .reticulum. So we have to cd into that, .ret tab to finish the line. Now we're in the right place. And if I... of course I could have used up arrow, but never mind. This is what's in there. Here is the config file. So let's nano config and take a look at it. There it is. That works. It's not working as a transport instance yet, but if you change that to true, then it would. Shared, yes. So if there are other programs using the Reticulum network stack, they'll be allowed to use it. Yeah, these are the very standard settings, which is great. Default interface. Of course, there are no other interfaces. So here you could add in an RNode, a radio node, if you wanted to. And you see that in my other videos. You could add in a public node here for use in the public Nomad network. You could do. You can also add them, I think, using the Meshchat program, and that would then write those from the graphical interface. It would write those into this file, I'm pretty sure. So you can actually add a node that way as well. I'm going to do Control X to exit. What I mean is, if we run the program again, wherever it is, that one. Yeah, in the wrong directory. You, yeah, have to watch out with these things. Whoops. I've forgotten what the directory is called. Oh, Reticulum. Okay, so change to that. And then you try to run it like this. Now it'll run. You have to be in the right directory. Okay, it's running. So now I can go back to the web interface, which is this. Let's reload it because it was disconnected, so now it's going to reconnect. If you go into interfaces here, you can see that's the default interface that was in the config file. What you could do is to manually add them here. If you go there, oh, sorry, wrong place. Add interfaces here. Then you can add in an interface. There are various different types you can add. So one of those RNode interfaces, you could add various types of interface. And these, no doubt, would be written into the config file. Actually, I'm being nosy, so I want to check if that really does happen. So this Amsterdam testnet, let's say we want to use it. Add it. And then I have to restart this to be able to use it. So there's no restart button up here, is there? No, there isn't. Okay, so then we have to go back here, do Control C, and then let's have a look directly in the config file. So I'd have to do CD. Oh, I'll do it in stages so you can see the different things on the way. Yeah. Let's go here, and then we have to do CD into the .reticulum directory, sorry, and then do nano config, the config file. And let's take a look in here. Let's see if that's been added in. Oh, it has. Look at that. Previously, there was just the default interface, and now RNS testnet Amsterdam has been added to this config file because I did it using the GUI of the Meshchat program. So that shows that that writes into this config file in the .reticulum directory. That's good. I'm happy about that too. Okay, I think that's enough from me. I wish you lots of success with Reticulum Meshchat and setting it up on a Raspberry Pi. You see, it is possible. And please ask questions in the comments below. I'm learning as I'm going along, so I'm not an expert. But I look forward to reading your comments. I also enjoy when you write direct messages to me in the Reticulum network. And remember to subscribe if you'd like to see updates. Thank you for watching, and goodbye for now.